All right, these are your notes for section 2.1, and we'll be talking about integers, rational numbers, and whole numbers. So first off, we have a couple of definitions. Rational numbers can be one of two things. One, anything that can be written as a quotient of integers is a rational number. So quotients, remember, is our word for division. So anything that can be written as the division of two things is a rational number. Also, rational numbers are decimals that either terminate or repeat. So, to clarify here, a terminating decimal is one that stops. So to terminate means to end. So your decimal is going to have an ending point. It won't be going on forever. A repeating decimal is when we have a pattern of numbers that are going to cycle through or repeat. So for example, a lot of people are familiar with the number 2/3, which when you divide it out ends up giving you a whole slew of sixes. So we could write that like this with the bar on the top, and that symbolizes that it's a repeating decimal. Integers, we've talked about before. Integers are your counting numbers. They include positives, negatives, and 0. So -1, 0, 1, 2, etc. And then last up, we have whole numbers. And whole numbers are going to be your counting numbers that are greater than or equal to 0. So beginning at 0 and moving in the positive direction. 0, 1, 2, 3, 4, etc. So right here we have a lovely Venn diagram to kind of help organize our key vocabulary words. So in the outer box, all of these numbers will fall under rational. Okay, so all of the numbers we're going to be talking about are rational numbers. Even whole numbers can be expressed as a fraction. So for example, 5. 5 is really, we can think about it as 5/1. So because it is a quotient of two numbers, then it is a rational number. Then our next circle is designated to integers. So now we're not including decimals or fractions, but we are including negatives, 0, and positive numbers. And then our last innermost circle is those whole numbers. These are now only 0 and positive. So that's why it's the smallest. So each one is eliminating some values. So now let's place our numbers onto our Venn diagram here and see where they fit. So if we look here, 3/4 is a ratio. It's the quotient of two integers, and so that's a rational number. 9 would fall under whole number because it fits, it is rational. It's 9/1. It's an integer. It's a positive counting number. And then it's a whole number because it is positive. So when we put it in that whole number circle, we are now covering all of those categories. Our next number is 0.6 repeating. It has that bar to signify that, so it is a rational number. -13, we know it's not a decimal, so it's not going to go in the rational, but because it's negative, it's going to go in with the integers. -1/7 is again a ratio of two integers, so that's a rational number. -5 is not a well, it is a rational number, but it's more specific than that because it doesn't have a decimal. It is negative, so that means its best location is with the integers. 0 is a rational number. It's an integer, and it also qualifies for a whole number, so we can put it with the whole numbers as the most specific area for it. And last up, we have 0.35. It's a decimal, so that's going to go out in the outer part with our other rational numbers. All right, so now we would like to practice some graphing of our integers and rational numbers on the number line. So remember when we were learning about number lines before, it's important that you begin by putting a scale on your number line. And when I looked at these, I realized that I need to at least get to -5. And 7/2 is also the same as 3.5. So I know in the positive direction I need to be beyond 3.5. So I'm going to start my number line at -6. So this would be -5 right here in the next mark. Then -4, -3, -2, -1, 0, 1, 2, 3, and 4. And you can label all of your tick marks with values, but I chose to label every other just so it doesn't get too crowded. So first up, -3.7 tells us we always begin at 0, and then we are going to move negative, which is the left direction, 1, 2, 3. And then because of its 0.7, we're going to want to mark it a little bit closer to -4. So that's -3.7. -5 is a nice non-decimal, so we can make that dot right here. And then 7/2, we already said 7 divided by 2 is 3.5. So go to 3. 3.5 is halfway between 3 and 4. So just to practice classifying our numbers, we can look at each of these examples here and determine if they are whole numbers, integers, or rational numbers. So 5, is that a whole number? Yes, it is. Is it an integer? Yes, it is. So remember, integers, positive and negative counted numbers. This is positive, so it's definitely going to be that. And then it's also rational. So once you say yes, it's a whole number, then it will automatically be an integer and a rational number. Now 0.6, our next example, because it's a decimal, we know it is not a whole number. That means that it also cannot be an integer. But because it is a terminating decimal, that makes it a rational number. -2 2/3, it's negative, so right off the bat, that makes it not a whole number, and it has a fraction. Integer, it is not an integer because of that fraction, but it is a rational number. So mixed numbers are still rational numbers. -24, although it is not a decimal, because it's negative, it's not a whole number. It is an integer, because integers include those negative counting numbers. And it is rational, because any whole number could be written as a ratio over 1. All right, let's try a little application problem here. So a star's color index is a measure of the temperature of the star. The greater the color index, the cooler the star. Order the stars in the table from hottest to coolest. So we are going to make a number line to begin placing our values in order. So just like before, we do need to make sure we put a scale on our number line. And because our numbers here are so very small, we want to think about possibly using a smaller scale. So I'm going to place 0 here in the middle. And then I'm going to count by 0.05s. So this right here would be 0.05, then 0.1, 0.15, 0.2, and 0.25. Then moving in the negative direction, we have negative 0.05, negative 0.1, negative 0.15, negative 0.2, and negative 0.25. Also, if we read this carefully, it says that the greater color index, the cooler the star. So we know that stars over here are cooler. So maybe I'll write it in blue to signify cooler. And our numbers that are more negative are actually warmer stars. So first, let's begin placing our values on the number line. So negative 0.03 is in between 0 and negative 0.5. It's a little over halfway, so negative 0.03. Then we have 2.1, so we're going to go to the 0.2, and then it's just a little bit further there. Then we have 0.09, so that's just before the 0.1. And then we have negative 0.22, so 0.2 negative, and then a little bit further, it's going to get us to negative 0.22. So now, the question asks us to list the stars from hottest to coolest. So warmer stars were on our left, cooler stars were on our right. So now we just have to match up the stars. So negative 0.22 matched with Shala. I'm no scientist, so my pronunciation may be a little off here. Next up is negative 0.03, so that is Rigel. Then we have 0.09, which is Denebola. And finally, our Neb is our coolest star. So that's all we have. So now you guys can get to work practicing these skills in your workbooks on page 16, problems 1 through 6, and 15 through 17.